Welcome back. In the previous lesson, you learned about a data structure called the queue. In this lesson, you're going to write a Python program that lets you work with a queue of data. So in this lesson, we'll make the queue. I've already created a program with a dummy queue in it for those if you're my student, otherwise it's easy enough to write. And then we're going to add extra commands to allow us to enqueue, that is add data to the queue, and dequeue, that is take data out of the queue. And we'll finish by seeing how we can add extra code to check when our queue is full or empty. So just a reminder, a queue is a linear data structure. It's implemented in an array in computer memory. And there are two pointers, one pointing to the head of the queue, the front of the queue, and the other to the tail or the end of the queue. Adding data is called enqueue, and this is done at the tail of the queue, like new people joining a queue join at the end. Removing data from the queue is called dequeuing, and this happens at the head of the queue or the front of the queue. Just like in a real life queue, the person who leaves the queue is the one who's reached the front of the queue. So here's a queue implemented in computer memory. As before, we've got a series of numbered data locations, and some of those data locations are holding items of data. The computer will remember the location of the head of the queue, in this case position 0, and the location of the tail of the queue, in this case position 3. Data will be removed at the head and new data will be added at the tail. Some programmers will write this in a different way. They will have the tail pointer pointing to the final data value in the queue. In this case, position 2, and you can write programs perfectly well that way. I've got to choose one or the other, and I'm doing this. So my tail pointer will point to the free location at the end of the queue. And I've written an example. Here's a very big empty array. It's got quite a lot of locations in it. And because there are no items in the queue, both the head and the tail are pointing at location 0. And my program has a little menu in it with options 1, 2 and 3, and 1 is enqueue and 2 is dequeue. Those options don't work yet, so we're going to write the code to make them work. If you're not my student, you can easily write this menu, put it into a while loop, and then you can work repeatedly with the queue, adding and taking away data from the queue. So we're going to write code to make these queue operations work. First, I'm going to write code that lets us enqueue a new data item, and then some code that lets us dequeue, that is, read and remove a data item from the queue. So let's see what happens when we enqueue a new data item, add a new data item to the queue. The tail pointer is pointing to location 3. So we add data at location 3 and move the tail along by 1. So it's now pointing at location 4. So that's the sequence. Add a data at the tail and then move the tail along by 1. So I'll show you the code for that on the next slide, but see if you can write it for yourself in the meantime. You can pause the video. So here it is. We get the user's choice, and if they choose 1, that was enqueue. Get the data value from them using an input command. Add it to the array at the tail position, and then move the tail along by 1. So if you haven't written that already, you can copy this code. Next, let's write the code to dequeue an item from the array, from the queue. The head, if you remember, is pointing to position 0, and that's where we would dequeue the value from. So the value at the head is returned or output from the queue, and the head moves forward by 1. We don't need to delete the value at position 0 because the computer will now simply ignore that value. Because there's nothing pointing at it, it will just sit there and be ignored by the computer. Okay, so let's write the code to make that happen. You can pause the video and try and do it yourself. Here's the code. If the user chooses 2 from the menu, they need to dequeue a value from the queue. So we take the value at the head of the queue, and then the head moves along by 1, and then we can do what we like with the value. In my example, I'm just printing it out. So that's what happens when we dequeue a value. We take it from the head, and then the head moves along by 1. Just like with a stack, there are some restrictions. If the queue is completely full, so all the data locations are used up, you can't enqueue any more data. And if the queue is completely empty, which is how it begins, remember, you can't dequeue, you can't take any values out of the queue. But remember, the queue is implemented in an array, and an array doesn't change in size. It's got a set number of data locations. So how do we know that the queue is full or empty? Have a little think about that. I'll show you the answer on the next screen. So have a think about that. If the tail of the queue has reached the end of the array, then it's hit the end and you can't add any more data. And if the head of the queue has caught up with the tail, then the queue is empty. So that's how we would check it. I've left out from this the looping that I talked about last time, where we start again at the front of the array. That's a more difficult programming task, and I'm going to leave you with that as a final challenge. Okay, so you should know how to make a queue. Just create a big empty data array with 2 pointers called head and tail. You should know how to enqueue. We add data at the tail of the queue and then move the tail along by 1. And you should know how to dequeue. We take the data at the front of the queue, the head of the queue, and then move that along by 1. If the tail of the queue reaches the end of the available space, then the queue is full. And if the head of the queue catches up with the tail, then the queue has no items in it and the queue is empty. So add some further code to your program. You should have enqueue and dequeue working. Amend that code so that if the queue is full, we can no longer add data. And if the queue is empty, we can't take data from the queue. More challenges on the next screen. Write functions to do all of these different queue activities, to enqueue, dequeue, and check if the queue is empty or full. And here's a final challenge that I'm leaving for the more confident programmers. Remember that if the tail of a queue reaches the end of the array, then we can't add any more data. A good workaround for this is to move the tail back to the start of the array and carry on building the queue up there. This has to be carefully done so that you don't overwrite the head of the queue. So you'll need to check very carefully and arrange this with quite some clever coding. And you'll also have to rethink how we can tell if our array is full or empty. So it's not a simple programming task, but for those of you who are looking for bigger programming challenges, create a full queue program that operates with wrapping. So I'm going to leave you with that challenge. And this is the end of the series of lessons about the stack and queue. So next lesson we're going to look at even a new data structure called the linked list. So bye for now.